Hello friends, of lately have you been thinking of this question about what is engineering? Means if you are planning to become an engineer and these questions are coming to your mind as if what could be engineering, what are different branches of engineering, which engineering is best suited for me, or if the question like this, which are the best colleges that I can be to do a particular type of engineering. So students, this video is for you. In this video, I am going to tell at a stretch about what is engineering, what are the different branches that you will be finding into engineering. I will be talking specifically about Mumbai University, which different colleges are there, what kind of engineering will be offered to you, which are the best colleges that you can be into, and how can you select an engineering stream for yourself. Which are the most prospective fields which are there in the market at this particular moment. So I'm going to talk about all these things in this particular video, so make sure that you watch this video until its end. Now before I proceed further, let me introduce myself. My name is Professor Pankaj Lade and I have done my chemical engineering from Mumbai University long back. For a very long period, I have been teaching engineering subjects to a lot of engineering students and at a lot of different places. But students, this video is not about me, it is about you. This video is going to change your life. It is going to make you decide what you need to do in your future. So students, let's begin. Now basically, what is engineering? Students, engineering is nothing but simply taking some complex problem and finding a simple solution which is cost effective as well as it will be preserving the environment too. So that is what engineering is. So if you are thinking of, or if you have that view of improving the quality of human life as well as you need to preserve the environment, then my friend, engineering is definitely for you. Now let's come to the very first question, what branches you can be having into engineering. So friends, I can broadly classify engineering into two particular categories. The first category is called as core branches. The first category will be called as core branches, and the second category will be called as derived branches. Now we will be coming into the question that which branch is best suited for me. But before that, let's understand what different branches are there. Now engineering is not just going to college and learning something. It is also innovation. You have to be innovative. You can observe, see this, if you want to take an example of innovation. You are all at your home, I am at my studio, I am at my classroom, I want to convey some message to you. So engineering has helped me to reach out to you, isn't it? So basically engineering is nothing but innovation. So you need to get an idea about which engineering is best suited for you. But before that, you need to know the various branches, what branches are there and what every branch actually deals with. So if that idea becomes very clear in your mind, then it will become very easy for you to select a particular branch for yourself. So students, let's come back here. As I said, there are core branches and then there are derived branches. Now, everything which is related to production, anything that falls into core branches, and the branches that help to run these production units fall into the derived branches. Very simple differentiation. Branches which deals with actual production, that will fall into core branches, and the branches which are there to aid, give an aid or give a help to run those core branches are called as derived branches. So the very first branch that we can talk about in the core branch is civil engineering. Civil engineering. Now, as the name itself implies that most of the civil work will be employed in civil engineering. It will be included into civil engineering. So there is construction, there is designing, and lot of stuff is there. So all the construction that is going on around you, the development that you can see, either it is the construction of roads, or it is the construction of the dams, or the irrigation project, or the residential projects, or the commercial projects, whatever you see which is related to construction, every single thing falls into civil engineering. It's a very challenging field. Not just construction, but the designing part also comes into civil engineering. All the architects. Now, what an architect usually does, he will design, he will what you can say, give his idea, but then that idea has to be transformed into reality, and that work is done by a civil engineer. So civil engineering is one of the most reputed branches that you can be into if you are really want to become a good engineer. Now, as I said, construction work comes, designing work comes, and after this, after doing your engineering, you can do some specialization also. There are many specialized fields that you can be doing after doing your graduate engineering, isn't it? After you do bachelor's of engineering, later on you can go and do some kind of specialization. Either you can go for GATE, you can do MTech, ME, or you can go for MS also. So it gives you a cutting edge if you have a good amount of knowledge along with you. So civil engineering, everything that is related to construction, the designing part, every single thing will be falling into civil engineering. Now, I am just going to give you an overview of all the branches. Now, what these branches actually contain means the subjects that you will be studying into civil engineering or any other engineering that I am going to discuss. For these subjects, you should definitely go and visit a website called as www.mu.ac.in. Now, once you are very clear with what kind of engineering that you have decided, what kind of engineering you want to do, later on comes the subjects that will be included into civil engineering and any other engineering. For instance, civil engineering contains something called as strength of materials, fluid mechanics, then there is load analysis, there is structural analysis, SA1, SA2 we call it, and lot of such kind of stuff you are going to deal into civil engineering. You will be drawing big sheets also, so your drawing ability will also be checked over here. So if you want to really go into the depth of the subject point of view, then you should definitely go and visit this particular site and download the entire syllabus of civil engineering. There you will come to know what kind of subjects are there and what the subjects are going to deal with. So civil engineering, everything about construction, that's the first branch. The second branch, which is my favorite also because I have done it. So the second branch is chemical engineering. The second branch is chemical engineering. Now students, chemical engineering is a very vast field. Every single thing that you use right from the beginning of your day till you go back to your bed, every single thing deals with chemical engineering. Means the toothpaste that you take to brush your teeth, and the what you can say, the mosquito coil that you light it up in your when you go to bed, or the mosquito liquid that you apply, every single thing is nothing but chemical engineering. So anything that is related to production, you will need chemical engineers. Now the only problem with these engineering is, the chemical engineering is, that you won't find chemical industries in cities now. All the cities now, since as you can see that industries create a lot of pollution. So many major cities or metro cities now have transferred all their chemical units into rural places. So if you are thinking to relocate yourself to some rural place, many of the industries have shifted to rural places. For example, the Taloja MIDC, which is on the outer skirts of Mumbai. You can go to Dombivli, there is also an MIDC. So all these MIDCs which are developed, they are all outside the prime cities. So make sure that if you are willing to do chemical engineering, then you will have to relocate. Now get one idea very chemistry. Chemistry is only there for the first 2 years, means the first year and the second year when you go to your engineering. Only up to the second year you will be having chemistry, and that too not in very detail, only the overview of chemistry, just to understand the compounds. So you will not be doing BSc chemistry over here. So nothing like, don't make up your idea that you will be learning chemistry in chemical engineering. There are many unit operations that you will be learning. For instance, if I want to go ahead, then the third branch that I am going to talk about is mechanical engineering. So it's an evergreen field. Any industry you go, any industry, you will need a mechanical engineer. So chemical engineering and mechanical engineering, they both go hand in hand. Any industry which is a chemical industry will definitely require a mechanical engineer. But there are few industries which are purely mechanical based, they do not need chemical engineering. So that is the reason that mechanical engineering seats usually fill up at the beginning. So most of the students, most of the male students, isn't it? The male candidates, they usually try to get themselves into mechanical engineering because that is an evergreen field. Every industry that you see will require a mechanical engineer. So I was talking about chemical engineering, and along with that we will be definitely looking at mechanical also, because they both go hand in hand. Many of the subjects are there which are common to these both branches. For instance, there is something called as heat transfer. Heat transfer is studied by chemical engineers, as well as heat transfer is studied by mechanical engineers also. But the application is different. Mechanical engineers will learn heat transfer, which is required in engines, isn't it? So engines get heated up very fast and they have to dissipate that heat. So mechanical engineers will learn heat transfer keeping the engine point of view, whereas in chemical industry the heat transfer, if you want to heat something, for instance you want to create steam, isn't it? So you want to boil the water, so you need a boiler, and there this fuel will be used, isn't it? So it gets heated up. So this heat, once it is generated, the flue gases that come out after you burn something, the flue gases are also very hot. If you have observed the exhaust of an engine, if you have ever touched the exhaust of an engine, it becomes very hot. Why does it become very hot? Because the gases which are exhausted out, they are very hot, and that is the reason the exhaust of the engine also gets heated up. But can we make use of now this heat that is dissipated from the exhaust of vehicles? That heat is very minimal heat. You cannot make use of it, although research is definitely going on to utilize that heat also. But in industries, chemical industries, this heat is at a very large quantity, very large extent. So you need to utilize that particular heat. So chemical engineers also learn heat transfer. The basic concepts remains same in chemical as well as mechanical. Only the application becomes different. So mechanical and chemical engineering, they both go hand in hand. So make this point very clear that chemical engineering has nothing to do with chemistry. Now, I know that this video might not be sufficient enough to tell you in detail about a particular stream. I'm just going to give you an overview of all the streams. If you have any question that you want to ask me related to any of the branches, students, feel free to go into the comment section and ask me any question that you want. I will definitely get back to you with more answers. Now, once we are done with chemical engineering, now remember that chemical engineers can work at various places. They can work into medicine, they can work into food industries, they can work into petrochemical industries, isn't it? So anything that is related to production, a chemical engineer is definitely required. So that's all about chemical engineering. And as I said, mechanical engineering, an evergreen field. Again, lot of possibilities are opened up when you do mechanical engineering. Most of the times you have to work with machines. So these fields are all shop related. Shop related means you have to go on the floor, you have to go into the field to go and work, and and believe me students, it is really very challenging. Every single day you have a challenge there. You have to go there and you have to resolve that challenge. So this is what these streams are dealing with. Now, mechanical engineering, as I said, it's an evergreen field. You will be learning heat transfer. Then there is internal combustion engines. We call it as ICE. There is of course strength of materials. There is thermodynamics. Now, these subjects that I am telling you, thermodynamics is also learned by chemical engineers. It's a very important subject. So, mechanical and chemical engineering, they both go hand in hand. They have many common subjects. So either of the streams you have selected, both of them you are going to simply enjoy it. Now, once you are done with mechanical engineering, what happens is many of the students, they have their first option as mechanical engineering, and if they are not able to get into mechanical engineering, then what they do is they go to the next stream, which is called as production engineering. Now students, production engineering, you can call it as a poor man's mechanical engineering. Those students who are not able to get seats into mechanical engineering, they opt for production engineering. Now again, as I said, production engineering more or less it is same as mechanical engineering, but to a lesser extent. Production engineering will mostly deal with extrusion, molding technology. For instance, I'll give you this example. Have you seen the soap at your home? Have you observed the soap at your home? This soap has a definite shape, isn't it? Every single time you go to the market, you get a new shape, isn't it? For instance, if you take any popular product, so every now and then they keep on changing the shape of this soap, isn't it? So what is this? Nothing but, it is nothing but the molding technology. Not just a soap, but any other thing where molding happens, where this extrusion has to happen, there production engineering will deal into. For instance, if you take the shape of a biscuit, isn't it? So a biscuit is nothing but what? If you want to manufacture a biscuit, so what all things are required? So you need a chemical engineer, you need a mechanical engineer, and you need a production engineer also. All these people come together and they run the factory smoothly. So production engineering, if you are not able to get yourself into mechanical engineering, you can definitely go to production engineering also. Now, the next stream that I'll be talking about is automobile engineering. Now, basically, very long back, mechanical engineering and automobile engineering were both taken together. Remember, there is a subject called as internal combustion engines, which is there in mechanical engineering, and exact same subject you will find in automobiles also. So what is different in automobile engineering? In automobile engineering, you will not just learn about the various type of engines. There is a diesel engine, there is a petrol engine, there is a CNG engine, there is an LPG engine, there is some other technologies which are developing, isn't it? The electric car, or you can say the hydrogen fuel. So lot of technologies are getting developed. So mechanical engineering on its own was not able to handle all these things. So you need a specified engineering, and that is where automobile engineering has been started. So it will not just deal with different types of engines, it will also deal with the dynamics part, aerodynamics, isn't it? How can the car go faster than it can? So if you observe, there is a designing part. If you go to Formula 1 cars, isn't it? They design their vehicles, very specific order, isn't it? They have a streamlined body, they have a flap. So why all these things are needed? What kind of tires are required? How much friction should be there? Each and every minute detail will be taught into automobiles. So it becomes a very specialized branch. So if you have that willingness to do automobile, you have that willingness to work with cars, isn't it? Work with vehicles, then my friend, automobile engineering belongs to you. I had a very good student of mine who is now working with Formula 1 racers, isn't it? Now he had a passion for automobile engineering, so he followed his passion. He has worked in Rolls-Royce, then he has worked in Lamborghini, and now he's working for Formula 1 racing car. So this is how a person can grow if has an interest into a particular subject. So that was automobile engineering. The next engineering that you can be thinking of is electrical engineering. So the fifth one that I can talk, the sixth one I can talk about is electrical engineering. Electrical engineering. Now remember, electrical engineering just does not deal with power generation. Of course, power generation is one of the prime subjects that we will be learning into electrical engineering. Now you must have this idea, isn't it? Conventional energies and non-conventional energies, the renewable resources that we say. Once oil has been used up, it cannot be brought back. It is impossible, isn't it? It takes millions of years to make the production of oil, isn't it? Into the Earth's core, this process takes millions of years for the production of oil, and we are just utilizing it without thinking for a second. So at some point, entire oil, all this oil is going to get exhausted, isn't it? So you need to come up with different ideas of energy resources. So what those resources can be, how can we deal with it, is taught in electrical engineering. For example, the hydroelectricity, that means the electricity that has been generated with the power of water. Dams are constructed. So now if you observe, when you are going to construct a dam, civil engineers are required, mechanical engineers are required, electrical engineers are required, isn't it? So what is the need of an electrical engineer here? He will decide how much output has to be given to the turbine, isn't it? What output it can give us. So all this designing part is done by a combination of different engineers. So electrical engineering, it deals mostly with power systems, power generation, but not just that. I can give you an example. If you have to travel by a metro, if you want to travel by a metro, what is metro? It's a mechanical wonder, isn't it? But it needs electrical engineers also, the power transmission. So power is generated, but it has to be transmitted. Not just transmitted, it has to be transmitted effectively. Who will look after all these things? So here comes the role of an electrical engineer. So these are few of the core branches that a student can do. Now students now try to understand this thing very importantly. The derived fields are comparatively easier than the core fields. Core fields demand lot of dedication. They demand hard work. They are all challenging fields. You have to be sound conceptually, means you have to understand all the subjects with their concepts. You cannot go and just simply mug up the subject. That is not going to help you to become a very good engineer. So it becomes very important to decide at the beginning itself, are you ready to take up the challenge? These fields are going to test you. For the 4 years that you will be there in your engineering, these fields are going to test you. They are going to test your endurance. So make sure before you start thinking about going into these streams, are you ready to handle the pressure? That is all you will be taught into engineering. What is basic engineering? It makes you ready to handle pressure, isn't it? So a better engineer is nothing but what? One who can cope up with the pressure, isn't it? So this is what engineering is going to teach you. So if you are planning to go into any one of these streams, get ready to take challenges. So students, this was all about the core branches. Now let us go ahead and understand the derived branches. Now let's try and understand what you will be getting into derived branches. What all branches are involved in derived branches. Now as I said, derived branches are nothing but the branches which are going to help the core branches, isn't it? You are very clear with the core branches. Students, whenever someone approaches me, what engineering is best suited for me, I only tell one thing. Choose that engineering which interests you. This is very important. Have you seen this movie called as 3 Idiots? Over there, you must have come across this one dialogue. काबिल बनो, कामयाबी झक मार के पीछे आएगी. Why does he say Kabil Bano? What does he actually mean? He is trying to tell you that you have to take interest into the subject that you have selected. If you are out of interest, then you will not love engineering and your life is going to become miserable. So it becomes very important at the beginning itself to decide, to make your mind very clear about what engineering you are going to select. So I usually tell people, you find out your interest. Now again, people tell me, how do I find out my interest? That is very simple. One which creates joy while learning is how you can recognize that this particular field belongs to you. Now you must have definitely learned some vocational subjects into your 11th and 12th standard. If your mind is cluttered while writing codes, while writing programs, then you won't enjoy computer engineering or fields which are related to computers. But on the contrary, if you are finding it very interesting to understand what is thermodynamics, is that you are very interested in understanding how physics is working, then my friend, these are the streams that you should be going into. So this is what, if anything is creating a challenge to your mind and you are loving that challenge, so a core field belongs to you, isn't it? And if you are more into what you can say mechanical sort of thing, means if you want to write codes, you want to write programs, you want to do designing part of you, isn't it? You want to develop websites, you want to run codes, you want to test programs, then derived branches are for you, isn't it? So this is how you can make yourself very clear. Do not try to go into a stream where your friend is going or where the most of the people are trying to get into. So this is nothing but a herd mentality. Don't be a part of it. You decide for yourself where you want to go and what you want to achieve after 5 years of education. Now, why I said 5 years? Definitely engineering is done in 4 years. It is definitely done in 4 years, but I strongly tell people you take 1 year more to understand what you have learned in these 4 years. You take an internship, go and work somewhere, even if it is for free, even if you have to work without payment, go and work and sharpen your knowledge. Only then you will be able to stand in the market. There are a lot of people in the market and a lot of competition going on around. So make sure that you have that edge over everybody else. So go get those skills, train yourself. Only then you will be able to survive into this competitive world. So that is why I said 5 years. You learn your education for the first 4 years and 1 year you sharpen that knowledge what you have gained, isn't it? So that 1 year you take to gather more and more of what you have already learned. You clear all your basic concepts, learn new technologies, anything that has come into the market, and as I said, go and work somewhere. Do not think about the money at the beginning. Most of the students have this one question in their mind: what about the money that I'll be getting? Money part comes later. First, you go and learn something that is useful, that is going to help someone out there, isn't it? Nobody is going to shell out 1 lakh rupees to you, and you are not knowing anything. When will you get that 1 lakh rupees? When you show your worthiness, you show your talent, you show that you can resolve challenges. Only then you will be getting that amount that you are expecting. So make you go and check within yourself, isn't it? You can retrospect yourself whether you have that capacity, whether you have that ability within you or not, and then you can ask or you can demand for particular amount. So students, let's come back to the next question. As I said, derived branches, we will discuss derived branches also into detail. The most favorite branch of any student, if I go and ask 10 students, 8 out of 10 students will tell me that they want to go into computers. They want to do computer engineering, and if not computers, they want to go into IT, information technology. So these fields definitely are very close to each other. but they have some basic differences. I will be telling you what is the difference into computer engineering and into information technology, and then we will go into electronics and telecommunication also. So basically, computer engineering is nothing but anything that is related to computers, not just programming. Remember that computer engineers just do not know programming. Along with programming, they know other stuff also. For instance, there is one subject called as microprocessors. Now you know, if you have seen this advertisement of many of the mobile companies, they tell you that it contains Snapdragon chipset, isn't it? So and so number. It contains quad-core processor, octa-core processor, isn't it? Hexa-core, and so on. These names are popping up every single time. What actually is all these things? Isn't it? Now, how does a computer work? How does a mobile work? It has a chipset into it which is fed with instructions, and it simply follows those instructions. Who designs this chipset? Who puts instructions into the chipset? So every single thing is taught in computer engineering, which is not taught in information technology. IT usually deals with the front end. It does not worry about the back end. That means whatever you see on the screen is information technology. Whatever you do not see on the screen, whatever is going on, which is running behind the screen, that is what is known by the computer engineer. So a computer engineer clearly has an edge over an IT engineer. But if your mind is only and only into software development, if you do not want to go into the hardware part, now when I say hardware, it does not mean going and assembling a computer. Anybody can do it. That is not hardware. When I say hardware, it means learning the machine language, learning artificial intelligence, learning how the chipsets work, how the motherboard works. All these things will be taught into computer engineering. But IT, you will only study the software part. For instance, if you want to, design a database software, definitely Oracle is there, isn't it? So this designing part will be taught into IT engineering, but the machine language, the processing part will be taught into computer engineering. So that is why whenever the campus interviews happen, a college which contains both engineering, they contain computers as well as IT, where do you think the company will have their first options open? They will definitely go and select a computer engineer, and then if they do not find good enough engineers and if the capacity of intake is more, then they will go to the IT engineers, isn't it? So make sure that you make a wise decision whether to go into computer engineering, which will have definitely more amount of subjects than IT engineering. And believe me, all the fields of derived engineering are comparatively simpler than the core branches. Core branches are very challenging. Now, why I am such a supporter of doing core engineering? I will share you my story. I have done chemical engineering and I have worked into chemical industries also. There are my friends who have done chemical engineering along with me, but now they have shifted themselves from chemical engineering into computer engineering. They are working with IBM and HCL and many other very reputed software companies. They were able to make the switch. People can switch from core branches to any of the branches. Most of the times, the computers and the IT fields. Anybody can come into this field. That is why there is always a cutthroat competition that you will face into these fields. You will not have people only from your field. There will be people who will be jumping from other fields also. So you need to always keep yourself upgraded with good amount of knowledge. So that is why I usually tell people to do core branches, even if you do not do it in a very effective way. If you are stuck up at some place, you are not able to understand the concepts and you are totally frustrated, which usually does not happen if you really love the field. If you have that passion within yourself, it is not going to happen. But given a chance, if anything goes wrong and you able to cope up with the pressure here, you can always jump onto some other fields. You can do something better, isn't it? So that is why I am very, I favor the core branches much. It's not because I have done chemical engineering. It's not like that. This is what I have seen. I have seen people switching over from core branches into IT fields and still doing better than these people. Isn't it? So that is why I usually tell people go into core branches. Even if it is not your point of interest, but if you are able to get something into the core branches, get into here first. And if you are not very good here, if you become miserable, then you can any time you can learn something new and switch on to some other field. So computer engineering, it deals with the hardware part as well as it will deal with the software part also. Whereas IT engineering only and only deals with the software part. You will learn Python, you will learn C programming, you will learn HTML, you will learn database management. So all softwares, .NET is there and plenty of softwares are there which you will be learning into IT engineering. But these softwares, many of them, will be taught in computer engineering along with some hardware subjects. For instance, there is a subject called as computer graphics. There is a subject called as automata theory. Now again I am telling, if you want to know these subjects that I am talking, you can definitely go and visit the website that I have told you. It's called www.mu.ac.in. Go to this website, you will have the syllabus of all the branches. Download them, do your homework well, study them well, get into those subjects, what these subjects contain. They are all given in a very detailed manner. A subject is given and what that subject is going to contain in that particular semester. Everything will be given into that particular file. So make sure that you go and download those files. At least you download those files which make you interested, isn't it? For instance, if you want to go and take a look at what mechanical contains and what computer engineering contains, you can go and download these two streams, understand their subjects, what they are teaching, what the syllabus is, and then you can make up your mind where you want to go in. So computers and IT. Now, after this, the next stream that I'm going to talk about is electronics. Now there are two streams that we can talk about here. One is called as electronics engineering and one is called as electronics and telecommunication. Now sometimes people opt only for electronics engineering. They are not very interested into telecommunication. But I usually tell students why you are losing out on one subject, isn't it? One entire stream. Why do you want to lose out onto it? If you are able to get yourself into electronics and telecommunication, this is called as EXTC. Why not go there rather than to just learn electronics, which is called as ETRX? So if you get an option to go either into of the streams, I would strongly recommend you to go into EXTC. And if you do not get yourself into EXTC, only then you go to ETRX. Now, what's the basic difference? Both the streams have everything common except the telecommunication part. In telecommunication part, you will come to know how this mobile companies work, how these networks work. You are sitting at home, how Wi-Fi works, how the satellite is going to work, how it captures data, how it uploads it, how it sends it, how all these things work will be taught into telecommunication, isn't it? So it becomes an added advantage into your profile if you know telecommunication. If you are not able to find something good in electronics, you can always switch on to telecommunication. Telecommunication is one of the growing fields of human history. Remember friends, from here it is simply going to grow. There is no going back now. If you remember 15 years back, 15-20 years back in you can say 90s or the early 2000s, mobiles were what you can say very expensive gadget that people had. People used to see, isn't it, a person with mobile as Badi Asami, isn't it? So using mobiles at that time was so expensive But what is the situation now? Isn't it? The technology has grown so much. There are so many industries now. There is Jio, there is Vodafone, there is Airtel, and lot many players are there into telecommunication. So there is bright amount of chance that you will definitely be getting yourself into one of these branches. But this can happen if you know telecommunication engineering. If you only know electronics, then it's not going to help you out. Isn't it? Now, what you will have in electronics engineering, I will tell you that also. In electronics engineering, I'll give you a simple example. If you go to a mall, when you go to a mall, the door is closed, isn't it? You stand there is one sensor at the top, isn't it, of the door. It senses that a person is coming and the door automatically opens. What is this? It happened electronically. Something which is happening automatically. That is called as electronics. Now this was a very simple example. The remote that you take in your hand, the escalators which are going up, which involves mechanical engineering also, isn't it? The escalators need to be strong enough, isn't it? They have to carry their own load as well as the people standing on the escalators. They cannot fail in between. So these all things are what you can say when two people come together, mechanical engineers, electronics engineers, they come together and it happens. So if you remember, when there is no one walking on the escalator stops, isn't it? And if as soon as someone approaches, the escalators again starts on its own. Nobody has to go and push a button or something like that. This is nothing but what? It is all electronics. Now this was a very simple example. You go to ATMs, you withdraw money, isn't it? Automatically all the money comes out and it comes out in the exact amount. If you have put up 2,500, the ATM will not give you 3,000 rupees, it will not give you 2,000 rupees. It will give you an exact 2,500 amount, except when it gets broken down, isn't it? So this is where the electronics engineers come into play, isn't it? So not just electronics, all these things, basic things that I've told. There is a different field that you can enter. It is called as avionics. Not just avionics, there is robotics also. So all these things are having their base into electronics engineering. Some people who have their interest only into robotics, they go to pure electronics. They don't want telecommunication to divert them. So that is why this is where you can be selective. If you have something to do with artificial intelligence, something with robotics, then you can enroll yourself only into pure electronics. But if you want to take a chance and go into telecommunication also, then this is the field that you should be selecting for yourself. So that is all about electronics and telecommunication. Now let's move on ahead with the next stream, which is called as instrumentation. It is called as instrumentation. Now, most of the students do not directly go into instrumentation. I have seen students, when they do not get anything else, then they take a decision of doing instrumentation, because they anyhow has to do engineering. They are so willing to do engineering that they enroll themselves into instrumentation engineering. Now, students, don't be like this. If you have not got any other engineering and that is why you are going to instrumentation, then you will really be miserable for your entire engineering. Remember, switching over is very difficult. Once you have taken a particular branch in a particular college, forget about changing the college. It is next to impossible. Once you go into a particular college, it is an impossible task to go into a different college with a different stream. That has never happened. So be very clear what you want to select at the beginning itself, isn't it? So whenever you are going to take the admission, make it clear that where you want to go, because once you have entered the engineering, after you have taken one of the streams, after you have selected that stream, there is no turning back. There are possibilities where you can switch into switch into a different branch into the same college. That is possible, but that too takes tremendous amount of hard work. Means you have to clear all your subjects. If the field that you are going to get yourself into is a lucrative field, the college might demand some extra donation or something like that. You'll have to pay fees of both the streams because you are leaving a stream, isn't it? You are vacating that place. So no one is going to fill that place for 1 year. So you have to pay that fees. You are going to go into a different stream. Sorry, you are going to go into a different stream. You are going to learn something new there. So you have to pay the fees over there also. So there are many technicalities. If you want to change a stream, you want to change a branch, you want to go to a different college. So at the beginning itself, you should be very clear what you want to select, isn't it? So instrumentation is not just an option that you should be selecting because I have not got anything else. It also deals with a lot of challenging concepts. It deals with a lot of interesting things. I'll give you an example. Since I'm a chemical engineer, I have to work into industries. Now you know that industries are huge, they are big. I have seen industries which are 10 kilometers long. You cannot just go from one end to the other end just by simply walking. You have to take a bus, you have to go from one place to the other place. So chemical industries sometimes are so huge that traveling becomes a difficult task. Now let us assume that at a very far place there is a distillation column. A distillation column is basically where you put into vapors, isn't it? You heat something, you heat a liquid. Let's take an example of crude oil. When you buy crude oil, you have to separate petrol, you have to separate kerosene, you have to separate diesel from it, then you have to separate this fuel which is required in aircrafts. You will get wax from it, you get paraffins, you get lubricants. Everything is obtained from crude oil. It's a mixture of all these things. You also get natural gas. Sorry. You also get natural gas from the same crude oil. So how do I separate this? So what people do is they heat this crude oil. They create vapors of it. And then it passes into a distillation column. It's a vertical column with separated temperature zones. So there is a temperature of say 300 degrees Celsius at the bottom and there is a temperature of 100 degrees Celsius at the top. So from every point where the vapors are getting condensed, you have to note down the temperature, you have to note down the pressure. So it is impossible to go and take a thermometer along with you and go and check the temperature. That is not going to happen. You need sensors. These sensors are developed by instrumentation engineers. So that is how challenging it is, isn't it? If, for instance, you know that our city, all the metropolitan cities, are supplied water from distant places, isn't it? There are lakes, there are rivers which are very far from the city, but then still it is pumped over here. Do you think that a person goes and switch on the pump and then the flow starts and then he opens the valves and everything happens manually? Nothing is happening manually. Every single thing now is done electronically. Who does all these things? So you want to make sure that the valve closes after a particular time. Then it is studied, it is designed, it is engineered by whom? The instrumentation engineer. So do not take it as an option. It is also a very good field, a very challenging field. So make sure that if you want to go into instrumentation, do not take it as an option. Go with interest. Let's move ahead. Now students, let's move on to the next field. I have talked about instrumentation. Let's begin with the next field is called as mechatronics. Now mechatronics, it's a sandwich of two streams. You can make out from the name itself. So there is tronics, which stands for electronics, and there is mecha, that stands for mechanical engineering. I'll give you a simple example of what these people are learning. Now, have you seen how welding happens? Now, if you know that Royal Enfield does maximum of its production manually. They do the painting job manually, isn't it? They do the welding job manually, and that is the reason there is always a crunch of bullets into the market. You have to have a long waiting period to get one for yourself. Now why this has happened? Because everything, maximum thing is done maximum thing is done manually. It's a mechanical job, isn't it? But do you have to wait for a car? If you go to book a car, isn't it? What happens is you pay the money and within a day or two you get your delivery. Now what's the difference between the two? One place the things are done manually, and at one place the car manufacturing and other things, many things are done automatically with the help of machines. The welding part, the fitting part, lot of things. It's just an assembly line. You just have to, people are just needed there to take care if something goes wrong. Only then the manual part comes. Otherwise, every single thing is happening automatically. The welding part also. The welding part also happens automatically. If you really want to see how this works, go and visit the channels of NGC or the National Geographic Channel or the Discovery Channel, and you go and see how actually the production process happens of all these cars and vehicles, isn't it? Manual work is very less. How can I combine the electronic part and the mechanical part together? So for that, this branch has been designed, Mechatronics, which takes some subjects from the branch of mechanical and some subjects from the branch of electronics, and combined this branch has been emerged. So Mechatronics is also one of the upcoming branches that you can get yourself into. But the problem is there are only few colleges that you can get yourself into. Only few colleges, when I say there are only colleges which you can count by your fingers. So that is why the field is what you can say so crunched up. There are always many people trying to get themselves into mechatronics. So it's a competition to go into this kind of fields. So mechatronics, as I said, combination of mechanical engineering and electronics engineering. So these are all, you can say, derived branches which help the core branches. There are two very separate branches now, Although I have taken them into the derived branches, but they have their own individuality, they have their own existence. And the next two branches are, they might sound very close to each other, but of course they are not. One of them is called as the biomedical. One of them is called biomedical and the other one is called biotechnology, biotech. So biomedical and biotechnology. So these two fields, if you want to get yourself into, you should compulsorily have biology as your compulsory subject in your 12th standard. You need to have biology. If you do not have biology, you cannot get yourself into these two fields. Usually I have seen people who take up medical field, means they want to pursue a career into medical field. For instance, they want to become doctors or dentists or pharmacists, but somehow they are not able to get themselves into medical fields, but they still want to be related to medical stream. These people go into biomedical or biotechnology. Now I'll tell you the difference between biomedical engineer and a biotechnology engineer. Biomedical engineering basically deals with the instruments, with the equipments which are used in hospitals. For instance, you must have heard of this thing called as the MRI, isn't it? You must have heard this something called as an X-ray machine, isn't it? All these machines are nothing, the CT scan, all these machines are nothing but what? They take images of a human body, they find out the problem into the particular area, and then they reveal it, isn't it? So if something goes wrong with this machine, who will come and repair it? Someone has to come and see what has gone wrong with that machine. A doctor cannot go and repair it, isn't it? He knows only how to operate it. But what is the technical background of that machine? How it should be taken care of? What could go wrong with it? If something goes wrong with it, who will come and repair? So a biomedical engineer is a person who knows these things in detail. There are not many companies, there are not many players into this field also. The biggest player is Siemens. If you go anywhere, you will find many of the equipments, many of the imaging devices which are used in medical field belongs to Siemens. It's a very respected company into medical industry. I'll give another example. If you go to a dentist, you can see that chair, isn't it? It has a lot of fittings on it. It has a drill, there is a pump, there is a suction pump, then there is some water also coming. Lot of things you must have seen on that medical chair, which is you can see at a dentist place. Nothing but what? Who takes care of it? Who designs it? Sorry. Who repairs it if it goes wrong? So this was a very simple example, isn't it? So there are a lot many other things that you will be finding into medical field. So these are all taken care by biomedical engineers. There is always one biomedical engineer at standby in every single hospital where operation theatres are there. Operation theatres have lot of stuff, isn't it? They have something called as the fibrillators, isn't it? They give you a shock if something goes wrong with the person, if there is no heartbeat, so they give you a shock. So what is that? It is nothing but a device, isn't it, which is used into operation theatre. But what if it goes wrong at the exact same moment? Someone has to come and very quickly resolve the issue. Who will come? Who will run for that particular equipment? So a biomedical engineer is always staffed in big hospitals. Any big hospital you take, wherever you find operation theatres, a biomedical engineer is always present for all the operations. So that is what you will be learning into biomedical engineering. The next one is biotechnology. It is, as I said, it is a totally different field. It's a very upcoming field. It has not been there from ages. Biotechnology is basically dealing with what you can say. You must have heard something like this: BT cotton, BT brinjal, isn't it? So you are changing the DNA sequence of a particular life. Means there are many pests, isn't it? You sometimes face this problem. The farmers sometimes face this problem. They are not able to control the pests. So what they do is, these biotechnology engineers, they modify the strain of that particular living being to resist a different strain. So this BT brinjal or BT cotton, they are nothing but what? They are modified. They have been biologically modified. So you must have heard of cloning, isn't it? You are doing cloning. You are taking the sperm and the egg, isn't it? And then you clone a living being. So what is this nothing but? So this is nothing but biotechnology. So this is what you will be learning. This modification part will be taught into biotechnology. So that is the reason the biomedical and the biotechnology, these two fields, need biology also as one of your core subjects in 12th standard. So friends, these were all different core branches. Now sometimes people ask me, where is aeronautical engineering or where is naval engineering? Friends, Mumbai University, or for that particular case in entire Maharashtra, nowhere, none of the colleges teach aeronautical engineering or naval engineering. These are specified for specified fields. Usually there are many colleges which will tell you that we teach aeronautical engineering, we teach naval engineering. But if you want to ask me, if you want to take my suggestion, I strongly will tell you, give the exams of NDA, and from there only you should be selecting a college. They will be providing you with the expert guidance, all the syllabus, everything, training, very rigorous training happens. So if you are willing to get yourself into aeronautical engineering, or you want to get yourself into naval engineering, I will not suggest you to do it from these colleges, the colleges which offer you from Mumbai University or say Maharashtra University. I strongly will recommend you only do it from NDA. So if you want to go and check for the branches, go and visit the websites of NDA. So there you will be getting all the details. There is another one field called as mining engineering. But again, as I said, mining engineering is also not included in our universities. That is why I have not discussed what mining engineering is. It is very much related to mechanical engineering, but female candidates are not allowed in mining engineering. Now there is this one myth which usually runs around, that computers and IT and these all fields are for girls, and mechanical, civil and all these fields are not for girls, they are only for boys. This this is absolutely foolish statement. I had students who were females, but they were still better than their male counterparts into core fields. So it is nothing like that a girl cannot go into core branches. There are branches have too much challenges. You have to go on the shop floor. Of course, you have to go on the shop floor, but it does not mean that the girl can't do it, isn't it? So she has an equal amount of chance to do this engineering also very effectively. So the girl student should take this thing from their mind out, that core branches are for boys and the derived branches are for the girls. Absolutely not. So if you are finding something very interesting, very challenging about the core fields, you should definitely be getting yourself into the core fields. I personally feel that a person should first try to get themselves into the core fields, and if nothing works out there, then you can go to the derived field. So this is what I would be doing. So friends, I hope whatever discussion I have done today, at least some part of engineering must be now very clear in your mind. I know this was a very long video, but I still appreciate your patience, because you have watched it entirely to understand what basically engineering is. I hope that many of your questions must have been answered. But if there are still more, if you still want to know about the particular field in detail, you can definitely ask questions into the comment section below. I will make every effort to get back to you with all the possible answers, so that your doubts will be cleared. I hope you must have liked this video, friends. If you have really liked it, please show your appreciation by hitting the like button, by commenting into the comment section. And as I said, if you have any questions, please feel free to ask any question. I thank you all so much for watching this video. You all have a great day ahead and an exciting career ahead. Thank you so much.